Welcome everyone to today's live talk. It's not rocket science. Today we're joined by Aditya, who's a software engineer from In-Space Missions. Today Aditya's going to talk to you about space and satellites, and at the end there'll be an opportunity to ask any questions. If you've not attended one of these live talks before, there is a live Q&A chat where you can put your questions in and it's moderated. And at the end, my colleague Sophie, who's joining us behind the scenes, will ask Aditya these questions. So please use chat throughout. And thank you very much for joining everyone. And I'll hand straight over to Aditya.
Thank you, James. Good morning, everyone, and welcome to my little talk on how to build a satellite. I've titled it, It's Not Rocket Science, because making satellites and sending things to space sometimes feels like it is very complicated, and sometimes it feels even like magic. What I want to do is explain to you how we make satellites, why we make satellites, and I want to make it less mysterious for you. So first, let me tell you something about me. I'll tell you 4 things. One is that I'm a software engineer and I have written software that will go on the next big Boeing airliner that's being made. I'm a cricket player. I play cricket on every weekend in the summer if I can. I love dogs. Even though I don't have one, I will always stop to pet a dog. And I'm a software engineer currently working at In-Space Missions, a company that makes satellites that are launched into space. Now, I'm sure you all know what a satellite is, but let me cover it again anyway. A satellite is a vehicle that is sent into space that sometimes can orbit around the Earth, sometimes can be sent to orbit other planets, or to observe the sun, or to observe deep space. Satellites can be massive. They can be large as the James Webb Telescope, which was as big as a building, and it's currently out there looking at galaxies in the universe. Or satellites can be as small as your palm, what we call CubeSats, which all they carry is a computer and a radio, and that's it. What more can I tell you about satellites? How do they get to space? Satellites are launched by rockets. You've heard of SpaceX, Elon Musk's company that launches rockets and satellites every 2 weeks. When they are launched into space, they can be as far as 60,000 kilometers above the Earth's surface, or can be in what we call low Earth orbit, 300 kilometers. In low Earth orbit, they can go around the Earth as fast as once every hour. But there is what is called geostationary orbit, in which satellites can be right above the Earth over one point at all the time as the Earth rotates. Satellites can be as small as a cereal box, or they can be as large as a bus. And all of them need solar power to operate. Some of them even carry batteries so that they can continue to operate when they are in the shade behind the Earth. But satellites have to be used for something. And for that, they often carry cameras or radios so that they can take photos of whatever they're trying to observe. So what can you get a satellite to do? Why would you use one for? You can use it to observe the Earth. So if you want to have an idea of what the weather is going to be like, or you want to monitor climate change, for example, then you can use a satellite with a camera that's pointing at the Earth, or you can use a satellite that is pointing out into space so that you can look at stars, you can look at galaxies, and then you can see what the universe used to look like and what it looks like to us today. But what about daily use? Everybody knows of sat navs and of maps on their phone. These maps work by using satellites to tell you exactly where you are so that they can tell you how to get to where you want to go in a sat nav or a maps application on your phone. Satellites are also useful for other things. If you want to find where herds of wild animals are going, and especially endangered species, you can use satellite enabled collars for animals to track these herds going across jungles and across deserts. But even more usefully, satellites can be used to make emergency calls. If you're stranded in the middle of nowhere, then you can use a satellite phone to call for help. So then how do you get a satellite to do what you want it to do? What exactly goes inside and on a satellite? One of the most important things that goes inside a satellite is the computer. Now these computers are not like your laptops or like the computers you'll find in your schools, but they are small microcontrollers which fit in the palm of your hand, but which are very powerful and which use very little electricity. But to use those computers, you need power. So every satellite these days has batteries on board. The batteries are very much like the batteries in your laptops or in your phones, and they provide power to all the equipment on it. But batteries only have a limited charge. So sometimes you need to charge those batteries and there is no electric power in space. So you use solar panels to charge these batteries. Now, if you want to talk to these satellites, you need some way to communicate with them. And we use radio. So you can have radio antennas on board and little radios that allow you to talk to it and to control the satellite. All of these things are placed inside the structure of the satellite. Now, the satellites these days are generally made out of aluminum, and they are built in frames like the one you see on your screen right now. And you can have things either inside the frame or on top of the frame because you want to keep these satellites small. So you try to use every inch of space available on them. But all of these things don't help you do what you want to do. So you need some equipment on the satellite that helps you complete your mission. And for that, you need what we call as a payload. In some cases, that can be a camera that can point either at the stars or to the Earth. So when you put all of these things together, you get something that looks like this. What you're looking at right now is a model of a satellite that my company has made. And you can see many of the things that I've talked about on it. You can see the cameras on top. You can see there is gold foil on the cameras to protect it from the sun because cameras can get very hot in the sun and the shapes of the lenses can change. So you don't want that. You can see many antennas on the side of the satellite, and you can see solar panels attached to it also. So this is what a satellite looks like. And so I would like to talk about what you need to study if you want to design one yourself. The main kinds of subjects that people at my workplace have studied are science and maths. Often they have degrees in related subjects. They're not necessarily space degrees. So there are people who have done electrical engineering like me. There are people who have done mechanical engineering and systems engineering, and people who have done science subjects like physics and maths are also quite popular because there's a lot of maths and science that goes into the design of satellites. You don't have to have a degree. You can come in as an apprentice or a technician. And then my company provides training. Many companies provide you with all the extra knowledge you need to help build satellites. But it always helps to have a passion in things like astronomy or computer programming, because these things are very useful in any sort of engineering role that you will find yourself in a company. Some of you might already be familiar with Python, the programming language, and it is a very useful tool in doing calculations and doing analysis to design satellites and to design how satellites will work in space. Given that, let me introduce you to some of my colleagues who build satellites, and you will have an idea of the kind of work that they do for us. This is Bob. He's an electronics engineer. He's got 25 years of experience making circuits that connect the computers and the payloads to each other, and they power the systems on board. Here he is in front of his electronic circuits, working in the lab, testing them out. This is Tom and Joe. Tom's in the front and Joe's behind there, and they're systems engineers. They figure out what exactly you need on the satellite to do your mission, and they tell you, and they will analyze the satellite and tell you how it will behave in space. Systems engineers are very common in the space industry because you have to understand how all of the components fit together and then they work together. Because once you launch a satellite into space, you can't repair it. And so you have to get things right very early on. So systems engineers are very important for us. This is Alice H. She's a mechanical engineer and she designs the body of the spacecraft that holds everything together. Now, one of the important things about this is that a satellite gets shaken a lot while being launched, and the structure has to be small enough to fit inside a rocket, but large enough and strong enough to withstand all the shaking and not break and not affect all the things in the satellite. And so one of our main jobs is to make sure that the structure is strong enough to survive this. There is Alex. He's a software engineer like me, and he writes the software that goes on the computers in the satellite that will allow you to control the satellite itself, and then it'll allow you to control the cameras and all the radios on board. This is Alice O. She's a technician. She makes all the connectors that connect all the equipment together on the satellite. Here she is sitting in the lab wearing protective equipment because they work with electricity. And she also solders chips onto circuit boards that connect everything in the aircraft, in the satellite, sorry. This is Lewis. He's one of the most important people for us. He's what we call an assembly, integration, and test engineers. These are the people responsible for assembling the satellite together at the end and then testing them out in big vacuum chambers on the ground and testing them up to very high temperatures and very low temperatures, because either in direct sunlight, a spacecraft can get very hot, or when it's in shade, a satellite can get very cold, and we want to make sure that it is working in all sorts of conditions. So Lewis is responsible for assembling the satellite correctly and then testing it before it is launched. These are just a few of the engineers that you've seen who work in my company. Here you have Mohammed, Richard, Anton, and Harrison, who are operations engineers who talk to the satellite every day while it's in space, or who are systems engineers or quality engineers. And I want to make you understand that it takes a lot of people working together as a team to build a satellite and to make sure that it's working correctly when it is far away from you in space. But I've spoken a lot about engineers so far, and I want to let you understand that you don't have to be an engineer to work in the space industry. If you want to work on the science and technology side, you can start as an apprentice. You can do courses in software and join as a programmer. You can be a technician like Alice. But if you don't want to go in through the maths and science side, we have people in finance and marketing. We have IT engineers who look after the computer equipment and the networks at work. And you can be a manager because we have projects that need managing, and we have people we need to manage so that they have the work that they need, and they can then be looked after so that we also have a good time while working, and it's not just work all the time. At the end result of all of this is you get one or more satellites that are designed, and what you get is a very happy team. So here is us in the lab after we finish designing and just before the satellite is sent to the Rocket Launch Center to launch into space. You can see some of the colleagues that I've already introduced to you before, but there are many more here. We have Theo and Hannah, who are operations engineers. You have Andrea and Nick who are in finance. You have Rob who's a mechanical engineer. You have Michael who's in charge of sales. And it takes a whole lot of people working really hard, but they come together to make something that is really cool at the end. And that is how a satellite gets made. Thank you. I hope you've enjoyed listening to me. And now I'd be very happy if you have questions for me. So over to you, James and Sophie.
Thank you for that, Aditya. That was a great talk and really interesting. I've learned a lot about satellites today. Okay, so the first question that I've come through is, how do I get a job in satellites?
So there are two answers to that. One is you have to find out who has jobs open to work with. So our companies will have websites with lists of jobs that are available to apply for. And on each job, there will be a list of things that list of qualifications that you need to have so that you can apply for the job. Now, some of them will say that they need you need to be an engineer. Some of them will say that you need to be a technician or you need to know how to program computers. Some will say you need to know how to handle money and how to sell a satellite to customers. So you have to go and find out what jobs are available, and you have to see if your qualifications match. Now, if the best way to get into the industry is to study either science or mathematics, and preferably, though it's not compulsory, get a degree in an engineering subject, because a whole lot of engineering degrees are applicable to the space industry. So you can be a mechanical, electronics, software, thermal engineer, or a quality engineer, and then you can join companies like mine and help build satellites.
Okay, so there's lots of different types of engineering that you can do and to go into that work. So I've got a question here. How do I become an assembly technician? So I think before you mentioned about apprenticeships.
Yes, so that's a very interesting question. Thank you. Assembly technicians, for us, you don't need to have an engineering degree for us to apply. You can do what are called vocational courses. I may be getting the term wrong here, but they are the T levels, if I'm not mistaken, Sophie?
Yes, there are, yeah.
The T level qualifications. So if you have some level of experience in understanding how things connect together, or if you have some experience in soldering or building electronic circuits or connecting wires, that is enough for us. You can apply and we will interview you. And then if you're successful, we will hire you as a technician.
Okay, fantastic. So I've got lots of questions coming through, which is great. So I've got a question from Milo. Do you have to be good at science and maths to get a job?
It helps. You don't have to be good because there are other roles which do not require maths and science. For example, in HR, we have people who are responsible for managing the people who work at InSpace. Now, if you want to be an engineer or if you want to work in designing a satellite, then yes, you have to be good at least maths or science, preferably both, to be part of the design team.
Okay. So is it expensive to make a satellite, Jacob asks?
It can be. Now, the smallest satellites that I mentioned about, the cube satellites, they can be very cheap and they can cost just a few £1,000s. If you want to build a large satellite, then it starts to be expensive. they can cost millions of pounds to build, and the larger you want to make a satellite, the more expensive it is. So it can be in the millions of pounds. There is also the things like the James Webb Telescope, which are in the hundreds of millions, if not the billions of pounds. But those are exceptions. Most of the satellites that you find in low Earth orbit, especially, are in the few millions of pounds.
Okay, so quite a few pounds there. Okay. So I've got a question. How many people are in the whole group to make a satellite?
So every satellite team is of different size depending on the size of the satellite and also how many we are going to fly together. Because sometimes we don't just launch one satellite, we launch them in groups of 2, 3, or 4. So that way you always need more engineers. The smallest team that has worked on a satellite at my company has been 8 people. And currently the largest one that's working on it is about 20 or 22 people.
Okay, so that's a big team then to get your satellite off the ground. So someone's asked, what is the average salary for these roles? So maybe you could just give a very sort of general indication.
Yes. So we have engineers who earn everything from 40,000 to, if you have a lot of experience and if you are an absolute expert in your in your field, the sky is the limit, to be honest, because such experience and expertise is always appreciated in the industry, and which means companies would like to pay you a lot of money to be a part of their team and to advise and to train everybody else in the company on how to best make a satellite.
Okay, great. What would happen if there weren't any satellites?
So that it would affect our life very significantly. The most important part for us actually would be that we wouldn't be able to predict the weather very easily. This would affect everything from farms to we would not be able to predict storms, and we would not be able to monitor climate change and how it affects us. That's one thing. But then you would not also be able to use your sat nav systems. So you would have to go back to using paper maps to navigate from one place to the other, which is always difficult. Instead of having a little thing on your phone that tells you exactly where to turn and exactly how far you need to go before you reach your destination. So these are just a couple of things. And then there is always the space side of things. We will not learn about the universe. And that is one of the things that excites me a lot about the space industry, is that we can look into the universe and see stars and galaxies and nebulae. And if there were no satellites, we would miss out on all of that.
Okay, so yeah, they're really important for the way we live our lives today. Definitely, we couldn't do without them, could we? Okay. So I've got a question from Ed. How long approximately does it take to build?
Sure. So satellite, if you want to build a satellite from scratch, it takes about 2 to 3 years, and I'm talking about the small ones. It also helps that if you have built them before, then all you have to do is get the new parts in, put them together, and then test it, and then it can take as little as 12 months to build a satellite if you already know how to build them. However, there are some satellites, again, like the James Webb Telescope, that take many years to build because they're large, complicated projects, and you have to get them right because you get only one shot at making such a satellite. So they can take as long as 10 or 15 years to build.
That's a very long time. Okay. I've got a question here from Lizzie. When was the most recent satellite made?
Oh, there are satellites being launched every couple of weeks thanks to SpaceX. For us, we made our most recent satellites were finished in December last year, and they were ready for launch by January. Our next satellites will be ready at the end of this year, hopefully to launch by March of next year.
Okay. I've got a question. What are the programming languages used?
Thank you. This is a question very up my sleeve. The main programming languages that we use are C, which is an old language, but it's still very useful for small computers because it is a very efficient language that is still used very widely. And we also use Python a lot because Python is very easy to learn and yet is very powerful. So you can do a lot of complicated calculations very quickly using Python.
Okay, fantastic. Got so many questions coming through. There's so much interest. It's brilliant. Okay, when was the first satellite made?
The first satellite was made in the 1950s by a country that is now doesn't exist anymore. It was called the USSR, which is now what Russia used to be. The first satellite was called Sputnik, and all it was a little ball that went into space with a radio, and all it replied to was a series of beeps just to tell you that it was in space and going around the Earth, so that we knew that they had been successful in launching the satellite.
Okay. Oh, have you always wanted to do your current job?
Actually, the answer to this is no. My first love, to be honest, is aeroplanes, and I have worked in the aerospace industry, so where I worked on aircraft. However, I've always loved astronomy and I've always been fascinated by space. So when I found out that there was a company in the UK, in Alton, where not far from where I live, that made satellites, I was very excited because they said they wanted a software engineer, and I was more than happy to apply for them. And now I'm lucky to be working in a company surrounded by a lot of cool people who know a lot of cool things that help build satellites.
Okay. How long does it take for the satellite to reach space once it is launched?
It takes just a few hours, especially if you're putting it in low Earth orbit, so which is about 300, 400, 500 kilometers off the ground. Then it can be in orbit in as little as a couple of hours. Rockets move very fast, so they can get there in a very short amount of time. And in fact, they take more time trying to make sure it is put in at the exact place than they take to actually get there to that height.
Okay, and just kind of following on from that, dear Poggabortzer asked, what happens if a satellite does not make it into space after it's launched?
That's a very good question. Thank you for asking. And the answer to that, unfortunately, is that it comes back down. Now, there are two important things about this. One is that rockets are always launched such that if something goes wrong, it happens over the sea and over parts of the sea that are unoccupied, so that there is no danger to anybody below them. And the other thing is, satellites these days are designed so that they burn up in the atmosphere, so that there are no parts left to come down and fall to the surface. So if once a satellite comes down, we make sure that it can burn up on the way down, so that nobody can be injured or affected by it on the ground.
Okay, so that's definitely good to know. We've had a couple of questions about what happens if a satellite breaks.
That's again the same thing. Now that's a slightly different question, actually, and it is a problem that people are trying to solve. When a satellite breaks up, it breaks up into little pieces that stay in the same orbit. And this is a problem, actually. And the problem these days is called space debris. Now, once it breaks up into little pieces, what the space industry does is try to keep track of these pieces and see where they are. If those pieces are going to affect other satellites, those satellites are moved out of the way by commands on the ground so that they don't get affected. Space debris is a problem that is going to affect satellites a lot in the future. So many companies now are doing very good work to understand how to stop it and understand how to clean up. Now, there have been very fancy ideas that have been proposed, like using really large nets to sweep it out of the way, sweep these parts out of the way, or to use lasers to burn these up in space. I don't know what will actually work in the end, but there are many companies that are now actively working to remove debris from space.
Okay, so that is definitely a problem that needs some ingenious solutions, definitely. So I think we've just got time for one more question as we're coming to the end now. How many satellites have you been involved in making?
So the answer to that is 3 that were finished, and 1, 2, 3, 4 that are currently being built. They're not necessarily separate projects, because sometimes one project can have many satellites in it. But there are 4 that we are currently building that I'm directly involved with.
Okay, fantastic. Have we got time for just one more question, James? Because we've still got lots and lots of questions coming through here.
Yes, yeah, go on.
Okay, let me just see. Okay, so I've got a question. Oh, this is quite an interesting question from Addy. So that kind of bit from when you're talking about breaking up the bits of the, what are the environmental repercussions of launching and constructing satellites?
Yes, now this is quite important, and there is no easy answer to this, because I mean, if you've seen us when you've seen a rocket launch, you know there's a lot of smoke and steam that comes out. Now, some of this is just steam, and which means it's just water that is there to cool the hot flames down so that they don't affect everything. But yes, there is some level of impact. It's not as large as, say, cars, or it's not as large as aircraft flying around the Earth. Rockets don't impact the climate as much as those things do. But it is something we have to keep in mind. So any rocket launch company has to perform environmental assessments to know that they're not damaging the area, and especially wildlife that live around rocket launch centers. And also, there are companies that are now trying to see research to see if the fuels that we use in launching rockets can be burned, can be environmentally friendly themselves. And the process to make these fuels is also environmentally friendly, so that we don't impact climate change in a negative way as we launch these satellites, sometimes to study climate change itself. So it is something that a lot of people are really working on today, so that we don't affect the Earth and the climate significantly each time we want to launch a satellite.
Fantastic. So that's sounds like an industry in itself, that sorting.
Yes, it is.
Sorting that. Okay, thank you so much for that, Aditya, for answering all those questions and for that really wonderful presentation that you've just given us. Just so everybody knows, we will be putting this on our website next week, and we will send out a link to everybody who's been joining us. And thank you very much.
Thank you so much.